Between Europe and Asia, economic dialogue, humanitarian missions, multi-vector operating and the search for compromises in the world arena. How else does Kazakhstan participate in the development of the modern world? More details, watch the program Kazakhstan International Vectors.
Today you will find out what does the Institute of Nuclear Physics in Kazakhstan, what are the main spheres of application of the peaceful atom, and how many nuclear power stations are there in the world.
Uranium has the atomic number 92. This chemical element is being widely used today in various spheres of human life, starting with medicine and ending with agriculture. Still, the nuclear power is the main consumer of this natural fuel. According to the forecasts of the IAEA, by 2030, rates of the global energy need can double. Modern world production is about 40,000 tons of uranium per year. At the same time, the annual demand for nuclear power reaches 70,000 tons. The deficit is obvious. In this regard, many states see their future in the development of a peaceful atom and even try to find new ways of extracting uranium, for example, from the seawater. An unconditional leader in the natural reserves of this fossil fuel today is Australia. According to the World Nuclear Association, the country possesses about 32% of all world reserves of this fossil. It is followed by Kazakhstan, with almost 12% of the global uranium reserves.
Vladimir Solodukin has been working at the Institute of Nuclear Physics in Kazakhstan for 54 years already, or almost from the day of its foundation. For him it is not just a profession, but also a real youthful dream which was destined to come true.
Я, пожалуй, единственный был из студентов.
Probably I was the only one from the students who joined the Institute of Nuclear Physics immediately after graduation. Although there were some other invitations to different leading universities, but since I had an agreement with the Institute of Nuclear Physics, I decided to follow it. Since then I have been working here, and I'm very glad that I have never changed my place of work. I really like what I do here. This institute is a special institution. It was founded in 1957 on July 25th. So this year it is 60 years since the foundation of this institute.
60 лет со дня основания этого института.
The Institute of Nuclear Physics in Kazakhstan was established with the goal of introducing the latest achievements of nuclear physics to all levels of industry, health and agriculture, Vladimir says. Well, in particular, we see here various samples of soils. Most likely they were selected on the shores of Kazakhstan's transboundary rivers. We study these soil samples, we monitor the transboundary rivers of Kazakhstan and Central Asian neighbors. Every year, or rather twice a year, samples are being taken. These are taken by the Republican State Enterprise of Hydrometeo Station of Kazakhstan. They have given these samples, and we are now about to analyze them. The institute has a large production potential. There are 4 large basic experimental installations here. They are an atomic reactor, an isochronous cyclotron, an electrostatic accelerator, and an industrial electron accelerator. All these facilities for a long time have been used for the studies conducted on nuclear reactions. Applied research was conducted which allowed developing the neutron activation analysis, which is also a unique analysis. At present time we also conduct forensic studies in our institute, commissioned by forensic experts. We are conducting an examination of nuclear and radioactive materials. About 700 people are working here, from which every 10th is a candidate or a doctor of science. For their research works, they have 22 scientific research laboratories and scientific and technical centers with modern analytical and testing equipment. Under the contract of cooperation with the largest organization in the field of nuclear energy, the IAEA acquired these semiconductor detectors. In this very laboratory, as well as in the whole center, in general, there are more than a dozen of such gamma spectrometers. They are of different types. They allow us to conduct research in various areas of energy. And the totality of this data, which we obtain while performing measurements on these spectrometers, makes it possible to obtain information on many radionuclides, in the environmental objects in particular, and in other types of objects if necessary. The field of application of radioisotopes is very wide. For example, they can be used in medicine for the treatment and diagnosis of different diseases, and in the production industry for the design of nuclear power facilities. We are now at one of these stages of the radiochemical analysis of samples from various sites, where nuclear explosions were previously conducted. Here in this case, we have samples from the Asgir object. At the Asgir, 17 underground nuclear explosions in a salt dome were carried out to develop the technology of creating special underground tanks.
Отработки технологии создания подземных емкостей.
As in any other research institute, a written analysis and accounting of the performed research is conducted here. All the information received during the research is processed in the information center and is issued in the form of conclusions and articles. We are in the production laboratory. The laboratory is called Laboratory of Low Background Measurements. At the moment, there are only 3 such laboratories in the whole world, and until now, our laboratory was the second one. One was at the IAEA, and then this laboratory was built here. The laboratory allows to carry out analysis with very high sensitivity, to conduct analysis in various objects. In this case, a procedure for mass analysis of samples is performed. The obtained results allow judging on the ecological, radioecological situation on the objects studied by us. At present, this laboratory is working on radioecological research. It is needed basically to study the deposits themselves, as well as to determine the elemental composition of minerals and rocks in these deposits. This is a liquid scintillation beta spectrometer. It allows determining the contamination of tritium, the concentration of tritium and strontium-90 in the prepared solutions, in specially prepared solutions. The Semipalatinsk nuclear test site today is called the nuclear tragedy of Kazakhstan. Previously, the first tests of nuclear weapons created in the USSR have been conducted here. 18,500 square kilometers of land were allotted for testing. The number of explosions reached several dozen a year. The inhabitants of the surrounding settlements, as well as watering soils, suffered from radiation.
Over the 40 years period from 1949 to 1989, 473 nuclear explosions have been conducted at the Semipalatinsk nuclear test site. They include 90 air, 26 ground and 354 underground explosions. In addition to nuclear tests, 175 chemical explosions have been done there. Studies of the territories that back then were affected are still being conducted today.
The decision to abandon the nuclear arsenal was one of the first which was accepted by the leadership of independent Kazakhstan. In 1989, the anti-nuclear movement Nevada Semipalatinsk was formed in the country. The organization's activities first led to a reduction in the number of explosions at the site and then to its complete closure. This was the breakthrough of the Republic in the humanitarian sphere. Since mid-1990s, or more specifically since 1993, Kazakhstan has been actively supporting the initiative of Kyrgyzstan and Uzbekistan to create a zone free of nuclear weapons in Central Asia. To date, this zone actually exists. And if we take into account that nuclear weapon-free zones are an integral element of ensuring nuclear safety, then of course Kazakhstan's role is great. This act was important for both the political future of Kazakhstan and for the world nuclear energy. Most countries took the course towards a peaceful atom. The movement of Nevada Semipalatinsk even today works actively with anti-nuclear organizations of France, Russia, the United States, Great Britain and India. The common goal of all these movements is the complete destruction of nuclear weapons. Kazakhstan was the first of the Central Asian republics in 1999 to pass a law on combating terrorism. Since this problem is now very global, it is also important for Central Asia. Although, of course, now all the Central Asian republics have adopted similar treaties, but it should be noted that Kazakhstan was the first of them to adopt this law, which, first of all, was aimed at preventing the acquisition of weapons of mass destruction by extremist terrorist groups. It is very important. Today, with the development of science, the peaceful atom has more and more possibilities. Nuclear technologies have long gone beyond the limits of research institutes. They are used in industry, for example in the production of elements for solar cells, or say in electronics. Uranium elements are strong, stainless and flexible. In agriculture, nuclear energy is used to change the properties of plants. The question of the safety of such plants for human health is still open, but the research is being actively pursued. In medicine, atomic energy began to be used much earlier and the results are already there. The most important direction is radionuclide diagnostics, which allows determining very accurately the stage of oncology. We are near the gamma camera, which is the main apparatus for studying patients with various pathologies of various organs and systems. At first, to diagnose patients, they are given the radioactive pharmaceuticals that accumulate in organs, systems, depending on their specific properties. Nuclear medicine exists in Kazakhstan since the 60s of the last century. Flagships of this direction in the country are the Institute of Nuclear Physics and the Scientific Research Institute of Oncology and Radiology. There is saline solution. There is a vacuum. It washes this column with an isotope which is inside. It only flushes out the technical solution. It enters the vacuum bottle, and this technical solution is further used to visualize the thyroid gland. Again, it is calculated and other compounds are labeled. After the calculations and packing, the patient is given intravenously a special drug containing radioactive isotopes. During the diagnosis in the gamma camera, they emit radiation which allows determining the concentration of cancer cells in the patient's body. Now you see how this device takes a position for the research. One detector records the patient from the front and another one from the back. This method was called scintigraphy or the functional imaging. It is absolutely safe because radioactive substances are eliminated from the body in just a few hours. Most of the isotopes that are used in nuclear medicine in Kazakhstan are now produced right in the Republic. For example, gamma radiators for diagnosis. The International Atomic Energy Agency, or IAEA, is the world's leading international governmental forum for scientific and technical cooperation in the peaceful uses of nuclear technology. In the organization's charter, the main goal is established to achieve a more rapid and wide use of atomic energy for the maintenance of peace, health and well-being of all mankind.
According to IAEA forecasts, until 2035, the total capacity of nuclear power plants in the world can grow from 7% to 82%, and the supply of the uranium production will be provided by Kazakhstan and, to a much lesser extent, by Australia, Brazil, China, Namibia, Niger, Ukraine and the United States.
Kazakhstan takes the second place in uranium reserves in the world. Under its ground, 12% of the world's reserves of this fossil occur. Its production in the country is currently carried out at 21 mines with a total production capacity of 22,000 tons per year. By the way, today at every nuclear power plant of the world, 1/3 of fuel is supplied by Kazakhstan, and in the future, this share will grow further. Kazakhstan, as one of the leaders of Central Asia, was the first to join the International Agency for Nuclear Energy, put all its nuclear facilities under IAEA safeguards, under the control of the IAEA, and thereby ensure transparency in its nuclear activities. This certainly contributes to the growth of trust between the Central Asian states and the formation of an atmosphere of mutually beneficial cooperation in the nuclear sphere. Because we know that in the Central Asian republics, with the exception of Turkmenistan, everyone is engaged in the extraction of uranium concentrate, and they are considered the leading suppliers of this raw material to the world market. In the context of using a peaceful atom, the security problem today is fundamental. 436 nuclear power plants are in operation all over the world, and 71 are now under construction. Securing safety in the use of nuclear energy is the goal set by each corporation which uses the atom for peaceful purposes. And it's not just that this energy should not be used as a weapon, but also that nuclear power plants should be as safe as possible in their operating process. The United States of America claims to be the leader in the use of nuclear energy for peaceful purposes.
In 1955, 1,200 inhabitants of a small town in the Midwest of the USA became the world's first community to completely switch to the use of atomic energy. The city of Arco, Idaho, has been being illuminated for more than an hour with the help of electricity generated by the boiling Borax 3 reactor.
In 2010, during the first Nuclear Security Summit in Washington, President of the Republic of Kazakhstan Nursultan Nazarbayev made his first statement on the idea of the Universal Declaration. This document calls on the world to free itself from nuclear weapons. During the Soviet period, the Institute of Nuclear Physics in Kazakhstan has been actively involved in the study of soil and water samples in the territory of the former Semipalatinsk nuclear test site. The whole territory is now well studied. It was revealed that in the vicinity of the landfill there is no threat of radiation for the local population. Now thorough research is underway with the goal to transfer part of the land to the needs of the national economy. This is a very big problem at the Semipalatinsk test site. There is a place called Balapan, which is the site of nuclear testing. And there the Ural River flows, and a lot of tritium gets into this river. A huge amount of tritium was found, and the river then flows out from the landfill and goes beyond the polygon where the access to this water is free for all. And now the question is being solved. Maybe additional restrictions on the use of this water can be introduced on this site. Today, one of the main and large-scale research tasks of Vladimir Solodukin is the monitoring of water quality in transboundary rivers in Kazakhstan. More than 10 years ago, studies have shown a certain degree of water hazard in one of the transboundary rivers. Now on the plans of Vladimir Petrovich to obtain permission to conduct a repeated research and, if necessary, to take security measures. Kazakhstan's membership in the UN Security Council proves that the world recognizes the achievements of the Republic, including the closure of the largest nuclear test site in Semipalatinsk. Since the first days of gaining its independence, Kazakhstan has pursued a policy of nuclear disarmament and not proliferation, not only on a regional scale, but also in a global dimension. With regard to Central Asia, of course, Kazakhstan, as the leader of the Central Asian region, an objective leader in all aspects, including as having inherited the fourth nuclear potential of the former Soviet Union and as integral part of geographically and politically Central Asia from the first days of independence, headed for a refusal from nuclear weapons. This, of course, is a huge contribution to the provision of nuclear security of Central Asia by Kazakhstan.
Независимости взял курс на отказ от ядерного оружия.
All questions in the field of nuclear energy today must be settled between countries and tightly controlled within the states. This requires laws, international meetings, and platforms for dialogue. Scientists are sure that in time, obtaining nuclear energy will become a common technology that does not threaten anyone.